Hello everybody and welcome to episode 19 of our video series in which we program an entire video game from scratch in the C programming language. First things first, we will go over just a couple of comments that were left by the viewers from last time. One viewer says, when calculating the offset for the animation frame, shouldn't you multiply the direction by 3, number of animation poses, and add the offset 0, 1, or 2? Either way, very cool stuff. Okay, so he is basically talking about where do we calculate our offsets. We did all this stuff a couple episodes ago where we basically make a sprite index to do or achieve sort of an animation effect, and let's see what else. In render frame graphics, we go right here and we draw an index of gplayer.direction plus gplayer.sprite index, and where we've defined those things right there. So essentially, and you can go and watch this. We did this like 2 episodes ago, I believe. But I remember when I was first trying to figure this out, I was like, I feel like there should be some multiplication in here, and I could have done it like that, but in the end, I think this direction plus index works just fine. And if I play it, it seems to work just fine. So I'm going to leave it like that. So in other words, yeah, I mean that you could have done that. More than one way to skin a cat. Next commenter says, and this person made this comment way back on episode 7, so it was a long time ago. It's whenever I inadvertently crashed the game while I was trying to do the clear screen stuff. He says, the crash at 1 hour was caused by the for loop writing too many pixels. Game drawing area memory size divided by 2 should be game drawing area memory size divided by 8. Or for more readability, game drawing area memory size divided by size of pixel divided by 2, etc., etc. Anyway, yes, I think we've got this worked out now. Essentially, yeah, when I crashed the game, it's because I was writing too many pixels and I was writing off of the edge of the screen. I was writing beyond the bounds of the back buffer, but we've got that fixed now. Works fine. Let's see, what else did I want to do? And that does it for the comments for today. So I'm just going to move on to whatever work we're going to do today. The first thing I wanted to do before I forget is I wanted to enhance our text function and just have our text function take a pixel to represent what color the text is going to be. So if I go to the blitzstring to buffer function declaration, I'm going to do 2 things. First, I'm going to change this from game bitmap to font sheet, just because that was confusing me a lot last time. That name confused me, so I'm going to change the name of that variable to font sheet, because that's what it is. It's our font sheet. And then in addition to that, I'm going to take in another parameter, and I'm going to call it color. I'll go down here to blitzstring, make the modification here, and I need to change this variable name oh good grief, Really? So yeah, the reason I'm giving you this look is because look how many of these I'm going to have to change. Alright, so what I'm going to do is I'm going to grab all of this. I'm going to grab all of that right there. I'm going to cut. I'm going to open Notepad. I'm going to paste it. And then I'm going to do a find and replace. I'm going to replace game bitmap with font sheet. Replace all. Okay, now I'm going to select all, cut, and paste. And the only downside is that Visual Studio indented our switch case block incorrectly again, so I have to select all of this and indent it properly again, right there. Should do it. Okay. Now, let's keep going with, let me copy this, paste it right here, paste. Okay, that's it. Now, we need to, this is in the render frame graphics function, we need to essentially make up a color, and we're going to make the color, let's make it green, I guess. So I think it's BGRA, so that's blue is 0, green is 255, red is 0, and alpha is 255. Okay. Then we will pass the address of our pixel in right there. And we'll see if it works. It did not. It did not work. Oh, I know why. We need to go back over to our blit string function. We need to go all the way down to the bottom, which is actually just a few lines up. Okay. I think that's all we need to do. Now we could probably, I'm sure we could optimize font sheet pixel out of the equation now, since we are passing it into the function as a parameter, but let's just see if it works first. There we go, it's green. Alright, let's go ahead and I guess I'll leave that I'll leave that alone for now. Let's clean up some of these warnings. Um, First of all, arithmetic overflow using multiplication on a 4-byte value, then casting the result to an 8-byte value. Okay, so heap alloc takes in a size t, which is an 8-byte value on a 64-bit operating system, and this is an int, and that's an int. I mean, I guess I could just make those size t. Just to make the warning go away. There it goes. So, I don't know though. The reason why I don't really like it, I don't really like doing that though, is because size t is 8 bytes, it's 64 bits. Size t is simply a data type that matches the bitness of the basically it matches the pointer size of whatever kind of machine you're on, 32-bit or 64-bit. But that's too much. I mean, that our bytes per character is never going to be that high. Our string length is never going to be that high. So I really don't think that it needs to be that big. So let's do something like unsigned 16-bit. So this way, as long as our bytes per character never exceeds 64K, 64 kilobytes for a single character sounds really unlikely in this game. So I don't foresee it happening. Unit 16. And same for these. I mean, even unit 16 is probably too big for character width and height. But you know, it'll be all right. Okay, so this needs to be. I will do the cast. Let's see what happens now. Clean, rebuild. Okay, I think that gets rid of those warnings and everything still works perfectly fine. Alright, let's see what's next. Okay, conversion from N64 to double. Possible loss of data. This is back in our WinMain function while we're calculating the CPU usage. And this is okay, so gperformancedata.cpu% is a what? It's a double. And then all of these are N64s. I mean, a double is 64 bits, right? So like a float is 32 bits and a double is 64 bits. Floats and doubles are what you use to represent if you want to express things in like decimal notation, you know, like fractional numbers like 1.5 and 64.25 and, you know, 3.14159, things like this. But I mean, oh, okay. What is the best way? Think of the best way to fix this. I don't know. Let's move on to the next one. We'll come back to that one later. All right. So now we're back to blitzstring initializing long to unit 16. That's fine. That's a long. Basically, just needs to be cast. Here we go again with this one. Sometimes trying to get rid of these warnings in Visual Studio is like playing whack-a-mole. They come and go. It's really annoying. Here's one in blit32 bits per pixel bitmap to buffer where it's telling us that we never actually used this variable background pixel, and I'm going to just comment it out because we are probably going to use it later down the road whenever we want to try to like blend two colors together. Like if you want to blend the foreground pixel and the background pixel together to make a third color. For example, if you're doing alpha blending, in that case we would need to know the value of the background pixel. But for now, we simply just don't need it. Okay. Unit 16, and these are in 32s. So our screen position, given that we know our resolution is really tiny, 384 by 240, our screen position is never going to be very big, so we could probably just change the definition. Where's our player? Here he is. And it's never going to be negative either, is it? Although I think making it unsigned would be a bad idea. 16 to int 16s. So 32,000 is the max for an int 16. Signed 16-bit integer. That should be fine. So about this, I'm just thinking the reason why I left them signed is because there will come a time when we want to draw stuff that goes off of the screen or comes in off of the side of the screen. So right now we've got things set up to where you simply just can't draw off the edge of the screen. I can't move my guy off the edge of the screen, or else the game will crash. But there will come a point where I want to actually update the function so that it will draw like a partial bit of a sprite, a partial amount of a sprite that is hanging off the edge of the screen. I know I'm going to want to do that eventually. So when that happens, the X and Y screen position of that sprite is likely going to be negative, like negative X coordinates or negative Y coordinates. And so it's important that we leave these screen position X and screen position Y as signed. So, all right, let's see if that's probably enough cleanup for now. Well, let me fix this one. So, yeah, 2 warnings left. And now this one, I'm thinking that there may actually not be a way to fix this warning without crashing the game. So I may just disable the warning for this line of code right here, because obviously I I can't cast that to a 128-bit value because of this pointer arithmetic. If I change this pixel 32 pointer to an M128i pointer, then what would end up happening is that every addition would move me 128 bits forward through memory instead of moving just 32 bits through memory each time I go through the loop. So, or each time that I add X my offset to it. So I can't change that. It's got to stay a 32-bit value. Alright, let's see what else. Oh yeah, I did want to show you, if I go to blit string, which I think is pretty good, but alright, if I go to string bitmap.memory, see where I am allocating memory for our temporary string bitmap? We're making a small rectangular temporary bitmap that is just big enough to hold the letters of our string. And then once we get to the end of the function, once we get all the way to the end of the function and we're done drawing into the buffer, and then we draw our string bitmap into the buffer, and after we're done doing that, then we can free the heap memory that we allocated for our temporary string bitmap. But if we didn't do that, I just wanted to show you what it would look like, what the memory leak would look like. So if I forgot to do that, if I forgot to free my memory, so I'm just going to comment that out. And so now what's going to happen is every frame when I'm drawing the words game over 60 times per second, I'm going to be doing that heap allocation 60 times per second. And I'm purposely forgetting to do my free. And so let's start it. And now let's switch over to Process Explorer over here. Okay, and now if I look at private bytes and just keep an eye on private bytes, notice that it's growing. Now it's up to 4K and 4.3K, and a working set is 11 megabytes. And if I just sit here and stare at it, it's just going to keep growing and growing and growing forever until I'm eventually out of memory. So yeah, if you want another look at it, oh yeah, these do refresh actually, so you can actually keep a look at it over, keep an eye on it over here as well in this tab. So yeah, anyway, so that's now that's what a memory leak looks like. And fortunately, the memory leak is very small. It's only like a few kilobytes at a time. But it will eventually grow until you have no more memory left on the machine, and the whole machine comes to a sluggish, unpredictable halt, and it would be bad. So if I, let's see, close that, run it again, and now you can see that the memory is not growing. Private bytes is steady at 2,412K, and working set is steady at 9,216K. All right, let's see what else is on the list. So there is something else that I wanted to do today, kind of a change of pace. I wanted to start sort of start a tangent on logging. And for example, at the very beginning of our program, we start in WinMain. All these message boxes, I don't like, none of those things are permanent. Like I want I want to replace all of those with my own custom logging type thing. And the reason that I want logging is because if I give this game, let's pretend that I have finished this game and I packaged it up, and someone else installs it on their computer and they go to run it, and something goes wrong. I don't know what it is, but something goes wrong. I want to be able to have a log telling me exactly what state the game was in, things like the current call stack, where it crashed, or if it crashed, or if something else went wrong. I want it to be able to log all of that stuff. I want to place an emphasis on logging good information that helps us debug the issue. That way, if something is going wrong with the game, um, we can just say, turn on the logging and reproduce the issue, and then let's analyze the log, and that should get us a lot farther in debugging the actual issue. So, but at the same time, I don't necessarily want to have all the logging turned on by default because people don't want to have megabytes worth of useless log files that they never asked for on their hard drive, and so um, yeah, it's probably not a good idea to have the logging turned on by default either. This is something that I deal with at work all the time in my work with the Windows operating system. Is a customer will be having a problem, and they'll open a case, open a ticket, a support ticket, and they'll be like, why did this happen? And then invariably we have to go in there and say, well, you didn't have the right logging turned on, so we don't know what happened. You're just going to have to turn the logging on and then wait until it happens again. So it kind of sucks, but at the same time, you can't just turn all the logging on and leave all the logging turned on by default all the time, because nobody wants all that logging running all the time. It has performance, implications if you leave the logging running all the time. It has implications for storage. If you have to store all these log files somewhere, if you have to rotate the logs, you don't want any one log file to become too large, because then it becomes cumbersome, and yeah, it's a lot to think about. Um, so first things first. I'm the realist. I'm going to create a new function. No, wait. I'm going to create a new data type first, or a new type def. I should say. A new struct, type def struct, registry params. This data structure is going to contain all of the various registry parameters that I'm going to, or that the game is going to load from the registry when it first starts up. Things like logging. So if you want to turn the logging on, you can go into the registry for this game and make a new D word that's like, logging equals 1 or something like this, to turn on logging. Other things that are going to be in here are going to be things like sound, like volume, like music volume and stuff like this. If you say, for instance, if you wanted to turn the music down to 50%, you would want that setting to persist. So every time you start the game, you don't have to reset the volume setting every time you restart the game. It's going to be stuff like that. So for now, I'm just going to put log level is going to be the only thing in there for now. Then we're going to make a new global, and we're going to call it registry params, g registry params. There we go. And now I need to create a new function, which is going to be called, probably returning keyword, load registry parameters. And is it going to take any parameters? I don't think so. I think it's going to look just like that. Okay, now back over to my C file. Let's create the function all the way at the end. Okay. Now in WinMain, we're going to call this function fairly early on. Get system info, get system time as file time, game's already running, set priority, create main game window, load the font. I guess we will just put it right in here. If load registry parameters does not equal error success, then go to exit. Okay. Okay, we need a handle to a registry key, H key. We need a D word called disposition. We need reg that's red equals 0. Actually, size of the D word. And the first thing we're going to do is result equals reg create key ex a. And again, this is Windows API stuff, so you can use the wide version if you want, or you can use the A version for ASCII. Doesn't really matter for our purposes. For this function, you type in basically one of the preset or predefined registry hives, just like HKey user, HKey machine, HKey or HKey current user, HKey current machine, HKey current user. Okay, and then a subkey of that, which will be software, and then what's our game name? We don't have one yet, do we? Yeah, we do. Game name. So this way, if I just make this string like this, that means that whenever we finally do change the name of our game, I don't have to come back and fix this function. So, there. Okay, reserved, I assume needs to be 0. Class needs to be null. Options 0. Desired key all access. Security attributes is null, and then the result is going to go into our reg key variable, and the disposition is going to go into the reg disposition variable. That should be fine. So I want to do like a log message right here. I want to create our own log message function. So let's put this on hold for right now and do that, because I want to get that out of the way. Apologize if I'm confusing. Okay, let's make our logging function. It's going to be called log message A. It's going to take in a log level, and it's also going to take in a message. And then finally, this is another cool concept. It's going to take in a variable number of arguments. So this is a pretty important concept in C. This is called a variadic function. So whenever I'm defining a function like this with this little ellipses or ellipsis parameter, it's basically saying this is an indeterminate number of arguments in the same style as like the printf function, for example. With the printf function, you can supply as many arguments as you want. It just needs to match the number of token specifiers that you write in your string in printf, right? So you can do the same thing. And this actually applies more to 32-bit Windows, but calling convention is important when you're writing variadic functions too. Standard call, or std call, which is what WinMain is, right? All of the Windows API functions are std call. And std call, that calling convention, actually cannot do variadic functions. Only cdecal can do variadic functions. Now, that works out perfectly for me because it just turns out that the default, if you go to somewhere in here, it's going to tell us the default calling convention, and it's going to say cdecal in here somewhere. There it is, calling convention. So every function in here, unless otherwise specified, is cdecal, which is cdecal is what you need for variadic functions. If you look over here at the documentation, it says because the stack is cleaned up by the caller, it can do var_arg functions. cdecal calling conventions creates larger executables than std call because it requires each function call to include stack cleanup code. This is that preamble and epilogue stuff that you see in the assembly that comes at the beginning and the end of all your functions that you don't write, but the compiler generates it for you. Yeah. So anyway, so there's our function declaration right there. So let's go back to the C file and write it. Okay, size t message length equals str length of message. System time. We're gonna log all of these messages with along with the time. There's a handle to our log file, and the reason I initialize it to invalid handle value is because the create file function, which we'll be using to open the log file or create the log file if it doesn't exist, that function returns invalid handle value if it fails. So it doesn't return null if it fails. Anyway, end of file, we need that variable. We need a number of bytes written variable. What else do we need? We need a buffer date time string that is big enough to hold our date and time. And I just kind of pick an arbitrary value there that I think is going to be long enough to hold any sort of like date and time that we're going to generate. Let's see, what else do we need? We need a severity string, which is going to be short. And this is going to be things like, is this log message informational? Is it a warning? Is it an error? That sort of thing. So like all of these log messages are going to have a severity associated with them. And then, let's see, and that's going to be 4K. So that's going to be the maximum size of the message that we're logging, which is pretty big. Okay, do I need... I'm not going to put a critical section in here just yet because I only have one thread, but later on, if we have more than one thread in our game that may be logging to the same log file at the same time, we may have to talk about critical sections at that point. But since this is just, you know, a single threaded game right now, it's not important. So the first thing we're going to do is we're going to check the log level. From the registry parameters, and I know this is sort of a chicken and egg situation because we haven't finished loading our registry parameters yet, which is we're going to load the log level from here, but for the time being, if it doesn't exist, it's going to be 0, right? Because this was initialized to 0. So when that happens, we're just going to exit. So the idea is that if the user doesn't have logging turned on, then nothing is going to get logged. If the user has specified that they only want to log errors, then we will basically only log errors here. And if it's like an informational message or a warning message, then again we'll just bail and not write them. So gives the user a lot of control over exactly what sort of log messages they want to see, which is nice. Alright, so if message length is less than 1 or message length is greater than 4096, then return and there's an issue of like in here, for example, do I want to tell the user that the logging function failed? Do I want to try to inform them in some way? Do I want to make a message box here, even though message boxes are kind of what we're trying to get away from? Do I want to do output debug string to try to output something to the debugger? Or do I just want to assert and crash the game? I don't know. But we have options. We'll come back to that. We'll think about it. Alright, so first thing is I want to do a switch on the log level. Let's see what our time looks like. 24. We still have a little bit of time. Okay. Oh, we need to make some log levels first, don't we? Alright, let's see. So we're back over here in our H file. We're going to do Log level none will be 0. Log level info will be 1. Log level warning will be 2. And log level error will be 3. Let's make an additional one. Log level debug 4. I guess debug messages will be just for us, basically. They may not even show up in the release build, but they'll help us debug. So I guess the idea is that debug messages are going to be even more verbose than info messages. They're going to be useless to anyone except for us, the developer, would be my assumption. All right, so let me think about this. If the log level is set to 0, destination, severity string, size in bytes, And by the way, just in case you didn't know about these switch case blocks, which I'm a big fan of switch case, but if you forget to put this these break statements in here, what will happen is you will fall through to the next case. So for example, if this comes in and log level is at warn, log level warn, then we'll go in here and we will copy the string warning or warn into severity string, and then since there's no break here, we're going to fall straight through to the error case, and then we're just going to overwrite what we just did with error. Now I think the compiler will warn you about that is going to happen, but with Visual Studio, it's hard to tell. You know, sometimes it warns you, and sometimes it doesn't warn you, even about really obvious stuff. So it's good to know. Let's see. Break. that it? Info, warn, error, debug. And I suppose if we log level none, we should just return. Okay, what's next? Okay, next thing we're going to do is we're going to get the time, and we're going to store that in our time variable. And now we're going to deal with our variadic, this variable number of arguments right here that they passed into us. So again, imagine like we are basically acting like the printf function right now, where we take an indeterminate number of arguments. And this is why that functions like this, variadic functions like this, have to be in the cdecl calling convention, because since we don't know the number of arguments coming into us, and that's why we can't clean up the stack. That's why the caller has to clean up the stack. See, it says because the stack is cleaned up by the caller. So yeah, so we the callee, as log message A is the callee in this situation. We don't even know how many arguments were passed into us because of this right here, because of this variadic thing, and because we don't know how many arguments were passed into us, we couldn't even do stack cleanup ourselves if we wanted to. The caller has to do that for us. So anyway. So we use this function right here to basically navigate these variadic arguments. VA start, and what did I do? I was typing list there, and I should have typed arg pointer. Pointer message and and here we're going to do a vn printf. I don't know the name of it. vn printf vn vsn printf s. Hey, found it. Yeah, so the we've used sn printf before, and then the v is the version of it that you want to use whenever you're dealing with a variable number of, or when you're dealing with these variadic inputs like we're doing right now. So let's see, formatted message buffer count will be size of formatted message. Oh, it's formatted string, isn't it? Yeah, formatted string. Max count, which I'm pretty sure you can just type truncate right here. And then finally we have the message. And the argument list. No, let's see. formatted string, and then this needs to be arg pointer. Okay. Did we do that right? Yeah, we did that right. Okay. Now, error equals sin printf underscore s, which there isn't one. I think you put an underscore here. Okay. Date time string size of date time string. And by the way, this size of only works right here for this date time string because we're using it's an array of known size. If we had been using like a pointer, in that case, size of a string would be 8 because it's no matter regardless of how long the string is, the size of function is not going to measure the length of your string in that situation. It's simply going to tell you the size of that pointer, and the size of pointers are always 8 on this platform. So size of only works correctly if you're dealing with buffers of known size, like the size has to be known at compile time like this. So that's why size of works. Where were we? Truncate, and then okay. Start with a new line. We're going to print the date here, so this needs to be. It's going to be a lot of format specifiers. U /% O2U %O, not to U, but just %U, and then %O2U, 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 point %O3. I think that's right. Okay, day. Year. Hour. Wait, time. Oh, sorry, I messed up. Month comes first, right? Europeans will not agree with this, but I'm doing month first. And then we're doing day. And then we're doing year. And then we're doing hour, minute, second. Not millisecond. And then finally milliseconds. Make sure I'm doing this right. Formatted message, formatted string, truncate message arg pointer, int. Okay, now what is our log file going to be called? Let's just name it game name.log. Should be fine. Now back to our function. Let's do log file handle equals create file log file name, desired access, pen data, share mode will be file share read, security attributes are null. We've already done a create file before whenever we loaded bitmaps, right? So I don't really have to explain all of these things again. Read null, open always. That actually may not be what I, yeah, I think that's what I want. I haven't decided yet. File attribute normal and null. Okay, if that equals invalid file handle, oh, invalid handle value, whoops, then what? Then I guess we fail. I don't know. I'll revisit it later. Haven't decided what I want to do in situations where the logging function itself fails, you know? It's like the logging function is supposed to log whenever other things fail, but what if the logging function itself fails? Then I guess you have to try to get a message out in some other way. You know, print to console or output debug string or something. Oh, by the way, I should mention, I never even thought to mention the reason why we're doing logging this way, logging to a file. Um, there are definitely other ways of logging in Windows, logging information. You could log to the event log, but there's a couple problems with that. Number one, if I wanted someone to send me the log file for this game because they wanted me to help them debug this game, I don't want the rest of their log file. Like, I don't want the application log file, right? I don't want like everything in their application log file or their system log file. I don't need to see all the rest of it. Secondly, and more importantly, I mean, yeah, of course, we could create our own log file, but more importantly, the Win32 event log API is a terrible dumpster fire, in my opinion. So I just never use it, and I wish I could, because it's efficient, and it's the way that a lot of other components and applications do their logging, and I would love to join in the party. Um, but from a Win32 and native code perspective, the event log API is complete and utter trash, and I hate using it, and it's terrible. You have to go and create all of these manifest files, and you can't just go and add a new event without completely redoing your manifest file, and it's just it's a total pain in the butt. So definitely not using event log. There's another way of logging in Windows, which is ETW, stands for Event Tracing for Windows. I really like ETW because it's also very fast and efficient, and you don't have to worry about things like um, log files. You don't have to worry about log files getting too big and all this kind of stuff. The downside is that you have to be um, you have to essentially be a complete pro to even know what ETW is, or to enable it. You have to be like an expert, basically. So essentially, the only people who use ETW are people who work for Microsoft, because it's so complicated that you have to know how to use Xperf or Message Analyzer, or um, it's good for you. You can write plain text strings to it, but the more common way to do it is to emit these binary strings that you can only decode with symbols. So the user wouldn't be able to decode the ETW file themselves without having symbols for the game, and they're not going to know how to do any of that. Um, so Yeah, that's out too. So we're back to logging to a file, because that's really the only way of logging for this kind of video game that makes sense. So that's why we're doing it like this. Um, right. Where were we? Let's continue. All right, we just opened our file. We have to go to the end of the file, so set file pointer, log file handle, distance to move, 0, null, file end. This is basically, we're just setting the cursor to the end of the file, so no matter how long the file is, we're going to the very end of it, and then we're going to append write file. And if you notice, there's no A and W version of write file. There's no ASCII or Unicode version of write file, and the reason why that is because write file doesn't write characters. It doesn't have any concept of narrow characters, ASCII characters, wide characters, Unicode characters. Doesn't matter. It doesn't know anything about any of that. Write file writes bytes, and that's it. It only writes bytes. So you can write whatever kind of bytes you want. It's up to you. But that's why there's no A or W version of this. Okay, buffer. Well, first thing we're going to do is we're going to write the date time string, and we're going to use str length. Number of bytes to write is just going to be the size of date time string, and we might as well cast that right now to a D word, or else it's going to complain. We're going to store that in number of bytes written, and overlap is no. And again, I don't even know how to deal with situations where the logging file or the logging function itself fails, so I'm thinking I'm not even going to check the return of write file. I'm just going to assume that it's going to succeed, I guess. The next thing we're going to do is write the severity. Is it not severity tag? Oh, it's just log level, isn't it? Log level. The length of. Oh, no, that is not it. That's not it. That's not it. Not it. Severity string. That's what I wanted. Severity string. Length of severity string. Number of bytes written, and null. And lastly, we are going to write our formatted message, which we created our formatted message right here. Formatted message, formatted message, formatted string. I always confuse the two. Number of bytes written, null. Alright. And finally, if log file handle does not equal invalid handle value, then we're going to close our handle to the log file. And I think that wraps it up. I think that's it for our logging function. Okay, so now that that's done, let's finish out our load registry parameters function. I know we sort of like switched context right in the middle of things, but I was having sort of a chicken and egg moment where I was like, does this need to come first or does that need to come first? But now we're popping our stack and we're going back to the thing that we were working on before, which is load registry parameters. So I think our log message function is complete. So at this point, I can actually call log message A from here and say, what is the log level? It's an error. And the message is going to be reg. Oh, this is going to be very cool. We're going to write in that, and it's going to be function W. Or sorry, we're not doing wide characters. We're doing ASCII characters, so that should do. So yeah, this logging function is going to log the function that we're in. Reg create key failed with error code 0x%08lx exclamation point, and the next will be result. That's nice. Now we have the ability to log error messages to a file. So the idea behind this is that, like I was just saying, this right here, this format specifier, is going to log the name of the function that we're currently in, which is a very handy thing to know if you're trying to debug things, right? And as we know, the function that we're currently in is load registry parameters. The second thing we're printing out is basically I'm writing 0x to let you know that what we're about to print is hexadecimal, and then the format specifier %08 means that it's going to be padded with 8 digits, basically, because we know result is a D word, so it is going to have 8. It's going to be represented by 8 digits, and then LX. L means long, and then X means print this as hexadecimal. X means print this as base 16. So that's how that works. Pretty simple. All right, let's go back to load registry parameters. Okay, go to exit, that's fine. If registry disposition equals created new key, then I'm going to say log message So now that we've created our logging message, I'm going to log so many messages. It's really an insane amount of messages I'm going to be logging because I like logging everything. And I can't talk and log at the same time. Log level info, and I'm going to say registry key did not exist. Created new key, H key, current user, software, percent s, right? Function A, function, and then this one is going to be it's just game name, right? Software game name, yeah. Game name. Okay, else I'm going to do log message. And I need to be prepared for the event that my log levels are actually backwards. They could be, but we will deal with that when we get there. Okay, opened existing registry key, H key, current user, software, %s. Okay. Result equals registry get reg get value a, reg get value A. It's going to be where's our key? Wait a minute. Returns an L status. Subkey. No subkey because we are already where we want to be. The value is going to be log level, right? Level. Flags is probably RF. RT keyword basically says it'll only accept it from the registry if it's of the correct type of dword type. It's going to be null. It's going to be a pointer to an array of bytes, and we're going to store this directly into Registry Parameters.log level, and then finally we need the address of bytes read. Now, I remember earlier, whenever I was messing with files, I was thinking that create file or write file was the API function where you have to actually input a number of bytes that you expect, and that's why I initialize registry bytes read to 4 size of dword. But you can't. This can't be 0 because if you put this in 0, it won't give you anything back. So you actually have to. This is actually an input and an output variable because you have to input to reg get value A the number of bytes that you expect to read, and then when the function returns, this will be the value. This will be the number of bytes that were actually read. So it's an in-out sort of thing. So if result is not error success, then we have a if this fails, we have a situation where basically file not found is sort of an expected error, right? Because the log level registry entry may not exist, and that's perfectly fine. If it doesn't exist, that just means that they didn't want any logging, right? So if result equals error file not found, if that is the case, then we're actually going to reset result to error success, because this is it's okay. If it was file not found, that just means that they never set the they never set it. So it's going to be log level info %s function, and I'm going to say something like registry value. Oops, please don't do all that. Log level not found, using default of 0. Log level none. Okay. And at this point, we already, like, log level is already 0 because it's initialized to 0, but I guess just for good measure, we'll keep it at 0, or set it to 0 again, I guess. Okay, anyway, so if the error was something other than file not found, that means that there was actually a real problem, in which case we will go to exit. But before we do that, we're going to have to log the failure. Log level error. Yeah, and I told you, I warned you, I'm going to log a lot. I like verbose logging. As someone who debugs things a lot, the value of good debug instrumentation is just, it's priceless. Okay, registry value. Let's see, failed to read the log level registry value. Error 0x% of 8LX. Function and result. Look good. Okay. And then after all of that, assuming that it succeeded, log message, log level info, we're going to say log level is 0, 1, 2, 3, 4. And I think that's it. Yeah, so all we have to do at this point, now later on when we have other things to read out of the registry, we will enhance this function starting right here. We'll come back to this, but as for now, we're done, because the only thing I wanted to put in here for now is log level. So if reg key, then reg key. Good. Let's see what we are looking like. It's looking pretty good. Now let's go up here to we actually need to load this pretty early on, because I would like to log some of these other failures as well. So essentially, we want to set up our log file as early as possible, because when we do that, we can log failures. We can log errors. So I'm basically going to make it first. It's going to be the first thing we do is set up our log file. Okay. So I guess let me go to the file. Let me go to users, source repos, game B. The working directory, I believe, is going to be right here. So let's see if a log file, if I run the game, no log file. Oh, but it's running under Visual Studio, so the log file actually isn't here either. It's not here either. Where are you, log file? No, that's Visual Studio's log file. That's not my log file. Okay, let me think about this. Load registry parameters. Let's go to regedit. HKey current user software game B. So that code did actually run. It did set that registry key. Load registry parameters. Oh, see, I think I may have my log levels inverted. Let's go to log message. Oh, it's not going to log anything because log level is set to 0. I literally, we sat here and programmed it, and then we're like, how does this work again? Let me set this to something else like 4. Okay. Now let's run it. We'll see if no log file. There it is. There's our log file. There we go. Load registry parameters. Log level is 4. All right, there it is. We have our log file. So logging works. And at this point, I'm going to start enhancing, basically going back through and enhancing everything that we've done to add more logging to it, to make our log file better and better and better, and have more information and more data in it, and it's going to be awesome. I have a feeling, though, that I'm way over time now, so that brings us to the end of today's episode. As always, thank you for watching, and please like and subscribe and tell your friends about this cool YouTube series. And don't forget that there is a GitHub repository that goes along with these episodes, and I update it alongside the episodes so that you can follow along at home if you would like to. And if you have any comments on today's video or any video, please do leave your comments on the video, and I will address your comments in an upcoming episode. And I think that is all I have to say. So thank you very much for watching, and until next time, have a good day.